Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz Bemanon. My metric number is MA18276. So now our group represent lab 4 series and parallel pumps. For the abstracts, centrifugal pumps are regularly utilized together to build whether the stream rate or the pressing factor of conveyance other than the one get from a single pump. The stream rate and pressing factor got from the stream rate meter and manometer. For specific plans of the line framework, it could be reasonable to pick a various pump framework that meets the plan prerequisite. Two standard choices are incorporate design of equal and arrangement pump requiring removable execution prerequisite. For the introduction, the background. In general, a pump can be described as a mechanical device that, when placed in a pipeline, transforms mechanical energy from an external sources into hydraulic energy, causing liquid to flow from a lower potential to higher potential. Centrifugal pumps are often used in combination to raise the flow rate or delivery pressure beyond the capabilities of a single pump. It could be appreciated to consider a multiple pump system to meet the design requirement for such a piping system. Pump setups in parallel and series are two popular options that both has their own set of performance requirements. For the problem statement, the centrifugal pump is powered by an electric motor that can be set to any desired speed using the speed counter. The pump pulls water from a storage tank and returns to the tank through a flow control valve and a venturi or orifimeter. The divisional head H around the flow meter is also measured, and the flow rate Q is calculated using the meter calibration. And now for the objective, we can to demonstrate the principal operating characteristic of centrifugal pumps in series, parallel or single pump operation. Next, to determine the pump characteristic curve of pump in series and parallel configuration and single operation. Last but not least, to determine the power pump. Last but not least, for the scope, this experiment is only for estimating, measuring, and analyzing a single pump as well as pump configuration in parallel and sequence. For this experiment, we can both use series and parallel pumping apparatus. Many other components such as a power filter, a valve, a flow sensor, and others are used to collect the data for each experiment and setup.
Assalamualaikum warahmatullahi wabarakatuh. So I'm the next presenter. So let's proceed to the chapter 2, the theory. The centrifugal pump converts the input power to kinetic energy in the liquid by driving the fluid through a rotating system. Next is fluid is entered into the pump through a high-speed rotating impeller's eyes. Second, the fluid is driven radially by the pump. And the next is the impeller eye produce vacuum that pushes more fluid constantly into the pipe. So this is basically the formula of the centrifugal pump. So there is two type of pump, which is pump in parallel and pump in series. So the next chapter is chapter 3, method and procedure. So based on the picture, there is apparatus and material, the valve, manometer, water tank, and centrifugal pump, and also the flow rate meter. Let's jump to the experiment procedure. Experiment setup. Each device is controlled to prevent error on the experiment, as the outcome may be affected by an error of a pipe leakage. The flow rate meter shall be connected to the wire from the sensor. To load the water tank, the on button is pressed. The pump is on before the tank water level is reached. Fifth, open the valve to allow water from the tank to be followed through pipe 1 and the sensor transmit a signal to the specified flow rate meter. Next, the valve is opened for series pump at the first pump and at the center. 7. The valve of the center is closed and the valve for parallel pump is open of the first pump and also on the second pump. 8. Any data or signal from the sensor is forwarded for analysis to the flow rate meter. 9. Measurement is made of flow rate from flow rate meter. Last, the manometer pressure data is measured. The next procedure is single pump configuration. The first step is by turning the valve head to the right, the valve number 2, 3, and 5 are closed. Second, by turning the pump switch left, the single pump is turned on. Third, for adjusting the volume flow rate, the output valve is used. Fourth, the flow rate is recorded with the corresponding flow rate meter, pressure, and manometer. Last, the different volume flow rate will repeat step 2 and 4. So the first pump configuration is parallel. The procedure is firstly by turning the valve head right, valve number 3 will be closed. Second, by turning the pump switch to the right, both pumps are activated. 3. For adjusting the volume flow rate, the output valve is used. Next, the flow rate is recorded with the corresponding flow rate meter, pressure, and manometer. Last but not least, the different volume flow rate will repeat from step 2 to step 4. So the last is series pump configuration. First, the valve number 2 is closed and the valve head is turned to the right. Second, by turning the pump switch to the right, both pumps are activated. Third, for adjusting the volume flow rate, the output valve is used. The flow rate is recorded with the corresponding flow rate meter, pressure, and manometer is the first step. And the last step is step 2 until step 4 is repeated by using the different flow rates. That's all from me. Thank you.
Thank you. Hi, I am Alif Lukman, and I will continue the presentation with the result. As we know, we have three pump configuration, which is the first one is single, the second one is in series, and the third one is in parallel. First, we look at the single pump configuration, and before that, for all these three pump configuration, we have to calculate the net head, the power output, and also the efficiency of the pump. So we look at single pump configuration first. The formula to calculate the net head is H equal to P over rho G, which is pressure divided by density times gravity acceleration. And formula for calculate the power output is rho G QH, which is density times gravity acceleration times flow rate times head. And next, for efficiency, the formula is P output divided by P in, where P in is 0.66 kilowatt. And finally, we can get the overall result for single pump configuration. Next, we move to series pump configuration. The formula to calculate the head is H equal to H1 plus H2, where H1 and H2 is P divided by rho G. And next, for power output, the formula is the same, which is rho GQH. And for efficiency, also we use the same formula, which is P output divided by P in, where P in is 0.66 kilowatt times 2. And finally, we can get the overall result for series pump configuration. Next, we move to the parallel pump configuration. The formula to calculate net head is H equal to H1 plus H2 divided by 2, where H1 and H2 is P divided by rho G. And for power output, we use the same formula, which is rho g QH, and also efficiency, we use the same formula, which is P output divided by P in, where P in is 0.66 kilowatt. And finally, we can get the overall result for parallel pump configuration. Next, we move to the pump performance curve graph. As we can see here, all these three graphs has the same relationship between volume flow rate and head pump, where head pump is inversely proportional to volume flow rate. This is because as the volume flow rate increase, the head pump will decrease. And next, we look at the comparison of pump performance curve graph. From here, we can see series pump has the highest. A series pump configuration has the highest pump head. This is because when connect in series, the total head developed is addition of H1 and H2, where H1 and H2 are heads developed by pump at common flow rate. And next, we also can see the parallel pump has the highest volume flow rate. This is because the resulting output curve is obtained by adding their flow rates at the same head. And that's all for the result. Next, we look at discussion that will present by Amirul. Thank you.
Thank you, Alif. My name is Muhammad Amir Hakim bin Alias, and I will continue our presentation, which is the discussion of this experiment. So, the difference between a single, series, and parallel pump. The first one is single pump. Our experiment tells us about the effects of pressure drop, pump strength, and performance of different pump configurations. In the experiment, we build and test single, series, and parallel pump. The data from these three experiments is used to create a graph of pump output. The required flow rate of the pump is defined by the fluid height to be pumped. The relationship between head and flow rate is described by the pump efficiency curve. The higher the flow rate required for the pump, the lower the head created by the pump. In terms of the relationship between pump head flow rate, we can see a pattern. The pump head is inversely proportional to the flow rate according to this relationship. The flow rate and pump head decide the pump power usage. The power changes for single series are the same according to the experiment. This is due to the fact that all pump configurations have the same purpose. They have the potential to generate a lot of head. Power output is equal to the flow rate and pump head. As a result, increasing the flow rate and pump head would increase the pump power output. Next, I will explain about the series pump. The design of the pumps has a significant effect on the supplied flow rate and net head to the system, even though two similar pumps are used in a piping system. In system with high head pump, the series pump configuration is used. As the same flow rate, a series equivalent pump will output twice as the head of a single pump. The relationship between series and single pump setups is the same. As a result, as the pressure head rises, the flow rate rises as well. The head is inversely proportional to the flow rate, as seen by the relationship. Furthermore, as the pressure head increases, so does the power increase. If the pump head increases, more load is added and the power consumption rises. Finally, as the flow rate increases, so does efficiency. Performance is directly proportional to the flow rate, as seen by the relationship. The last one is parallel pump. The design of the pump has significant effect of the supplied flow rate and net head to the system. Even though two similar pumps are used in piping system, to deliver a higher flow rate, a parallel pump arrangement is used. The performance curve is obtained by applying the flow rates of two pumps connected in parallel at the same head. The flow rates double as two similar pumps are connected in parallel, while the head remains unchanged. The header structure that connects two pumps leads to same pressure for their suction and discharge interactions as they are joined together. As consequence, when the different pressure of head is the same, the overall flow they produce is the same as the flow provided by the engine. The overall output curve of the system is calculated by equating the flow delivered by the pump at a certain head. Furthermore, as the flow rate rises, the power demand rises with it. This is due to the fact that higher flow rate reduces load and as a result reduce power consumption. As a result, it will produce double the amount of flow while having less strain on the pump. The parallel pump efficiency is better than the other pumps since the consumed power is lower. So I will pass my to Azman to continue our presentation. Thank you.
As a conclusion, we have successfully done this experiment virtually based on the given video and collected data. We have known how to demonstrate the principal operating characteristics of centrifugal pump in series, parallel, or single pump operation. In this experiment, the kinetic energy of the Bernoulli equation is the energy given by the pump. The velocity at the impeller's edge or point is referred to as the energy transferred to the liquid. So, the greater the velocity of the fluid energy transferred to the fluid, the quicker the impeller rotates. And lastly, we also have determined the pump characteristic curve of the pump in series and parallel configuration and single operation by doing each configuration of the pump and done the calculation for this experiment such as net head, power and efficiency calculation. Thank you.